Hey again, Algebra 1 students, Mr. Jagler here. This is the second ALEKS topic for week 1. It's interpreting a tree diagram. If you haven't gone and done Introduction to the Counting Principle, which was the first topic of the day, I would go back and do that. So what we're looking at with this one is basically just interpreting a tree diagram that's already been created. So if you take a look at this first example here, it says a coin is flipped and a number cube is rolled. The tree diagram below shows the possible outcomes. Use the diagram to answer the questions. So if you look here on the left side, this is both possible outcomes for the coin flip. And the second one here is both or all 6 possible outcomes for a number cube being rolled. And then on the right side here, what they've done is they've written out each possible outcome in parentheses, which is a nice way of kind of summing up all of the data. So the first problem that they're asking is how many outcomes are there? That should be a pretty easy one because all you got to do is multiply 2 times 6 and get 12, or you can just count up these 12 outcomes here on the right side. So that's the answer to the first question. The second question, how many outcomes involve rolling a 3 or a 4? Well, if you take a look at our possible outcomes, we've got 3, 4, and then another 3, and another 4. The key word that you want to look at here is or. Okay, there's going to be some problems that are going to say and some that are going to say or. If it says or, it can be one or the other. It doesn't have to be both. Obviously, you can't roll a 3 and a 4 at the same time. So what we're looking at here is how many times do 3 and 4 pop up on our roll. So you see that we have 4 3s and 4s. Okay. Then the last one, how many outcomes involve tails and an even number? So with this one, we got to look at specifically all the ones that are tails. So this top section is not going to be included. So we look at tails and we look at all the tails with an even number attached to it. So we won't have this one, but we will have this one with the 2. Again, not the 3, but the 4. Not the 5, but the 6. So that leaves us with just 3 possible outcomes for that last situation. So we take a look at this one. This is probably going to make you hungry. Take a look at the 4 different types of crust that you can get for a pizza. You got pan, regular, stuffed, and thin. Then they have 3 different toppings that you can choose from: mushrooms, pepperoni, and sausage. The first question that we're being asked is how many outcomes are there? And once again, you see that there are, in fact, 12. The second question, how many outcomes have regular crust or thin crust? So looking at that one, we want to look for all the ones that have regular or thin. And if you look at the right side here with all the possible outcomes, we have 3 here with regular and 3 here for thin. So that would be 6 possible outcomes with that situation. And the last one, how many outcomes have both pan crust and pepperoni? Well, you would imagine that this would only show up once. And if you take a look at your outcomes here, you've got pan pizza right here in this top section, and there's only one where pepperoni is the topping of choice. So the answer to that one would be just 1. Kind of similar to the last one here, we had 2 different categories here, and it was really easy to kind of narrow down each one because we didn't have to go to a third column. That leads me to this one. So the directions here say we've got one spinner that's got 2 sections, and they're marked A and B. We've got another spinner with 3 sections that are marked 1, 2, and 3. And the third spinner that's got 2 sections, and those 2 sections are green and pink. We're going to spin all 3 spinners, and this column right here on the right is all of your possible outcomes. So as we've seen a lot of today, we have 12 possible outcomes here. You just count all 12 of these possibilities. It gets a little bit more complicated when you've got 3 categories like we do up here. So if you take a look at problem B, how many outcomes involve landing on B and an odd number? So B and an odd number, if we're looking strictly at B, we got to look down in this bottom section here. This is where all the B's are. And then if we're looking for odd numbers, we're looking for 1s and we're looking for 3s. So that would be 4 different outcomes that involve B and an odd number. The last question, it says, how many outcomes involve landing on a 1 or 2? Well, in that situation, we got to look throughout the whole set of outcomes because we've got 1s and 2s at the top, and then we got 1s and 2s at the bottom as well. So if we take a look at that and we count those outcomes up, we would have 8. So out of all 12 of those outcomes, 8 would have either a 1 or a 2 with this second spinner. Here's the last one that I have for you. We've got a class that's choosing a president, a vice president, and a treasurer for their student council. It says there are 2 students, Linda and Maria, who are running for president. You've got John and Bob running for vice president. And then for treasurer, we have Jessica, Amanda, and Deborah. So what we have here are the 12, again, possible outcomes that we could possibly have for these 3 positions. The second one that we're being asked here, the second question is, how many outcomes do not have Amanda being chosen? So we're looking for outcomes over here that do not include Amanda. Amanda was one of the students that was running for treasurer. So we've got this one, we've got this one, this one, this one, this one, this one, this one, and this one. So there's 8 outcomes where Amanda is not chosen. The third question we're being asked for this problem is how many outcomes have both Linda and Bob? So if we take a look at that, we've got these 6 outcomes here that have Linda. And out of those 6 outcomes where Linda is the president, 3 of those outcomes have Bob as her running mate for vice president. So that is some examples there for interpreting a tree diagram. So what I would recommend now is going back into ALEKS, looking this topic up. If you have it, do it. See if you can work through the problems on your own. If you don't have it, you may not have to do it because you may have already done it. If you are one of those students that has not had this topic done and does not have it unlocked, you may just have to do some of the prerequisite topics to be able to unlock this one. This is the last topic for day 1. So once you are done with these 2 topics, you are done. If you want to get ahead and do some more, feel free to go on and do other ALEKS topics that you have in your carousel.